Facilitators International Study Channel followers, how are you? Welcome to Facilitators International Study Channel Grade 12 Mathematics lesson in Ethiopian curriculum. My name is Yamata. If you're interested in my presentation, you can subscribe, comment, like, and also share. Now let us start our today's presentation. So limit theorems of a sequence. So before that we have seen some concepts about the limits of the sequence. So today which is the terms of limits of a sequence. Therefore here we can say as a theorem, let the sequence A and B and B sequence AN and BN be convergent sequence, convergent sequence, meaning is that so the limit of the sequence AN as n tends to infinity equals to some fixed real number n and limit of the sequence Bn as the value of n approaches to infinity equals to, let's say, m and let's say C is an element of real numbers. The number C is elements of real numbers. Then we have the following properties for limit theorems. Then the first party say we can say the limit of the sequence, which is say AN plus BN when the value of n approaches say infinity. We have seen here. So the limit of the sequence AN plus the sequence BN when n approaches to infinity, which is exactly equals to the limit of the sequence AN when n tends to infinity plus limit of the sequence Bn when n tends to infinity. So the result equals to the limit of the sequence n equals to L and Bn the limit which equals m. So the result is simply L plus m, we can say in such a way. So since the sequence n and Bn convergent have the limit L and m, so the limit of the sum of the two sequences, sum of the sequences have the value which is equal to simply L plus m. But if it is minus, so we can say the second part is the limit of the sequence, the same fashion here, simply an minus bn when the value of n approaches to infinity is exactly equals to the limit of the sequence an when the value of n approaches to infinity minus limit of the sequence bn when the value of n approaches to infinity. The result equals simply L minus m. So if it is plus, እንግዲህ ሁለቱ ኮንቨርጅ ካደረጉና ሊሚት ካላቸው የሲኩዌንሶቹ ድምር የድምራቸው ሊሚት እና የልዩነታቸው ሊሚት ራሱ ፊክስድ ሪል ነምበር እናገኝለታለን ነው የሚለው። በሶስተኛ ደረጃ የምናገኘው ሳድ ፕሮፐርቲስ say that the product limit of the sequence, which is some sequence with some constant value c times the sequence an as n approaches infinity, which is exactly equal to, we know that c is any constant number which is real numbers. This is exactly equal to c constant outside the limit, which is equal to simply c times limit of the sequence an when n approaches to infinity, but this value is exactly equal to L, so the result equals simply c times L c times of L. The fourth property says that fourth part limit of the sequence say an times of bn, the product which the sequence product of n times bn when the value of n approaches to infinity is equals to limit of the sequence an as n approaches to infinity times of, and again limit of the sequence bn when n approaches to infinity. So the result is this becomes say n, and this becomes say m, which equals simply n times n እናገኛለን ማለት ነው። The fifth part is that as a quotient. So the limit of the sequence an over bn like this when n is approaches to infinity is exactly equals to limit of the sequence an when n approaches to infinity over limit of the sequence bn when n approaches to infinity is exactly equals to simply n over m. Provided that here the limit of the sequence, or we can say simply m is differ from 0, or the limit of the sequence bn when n approaches to infinity equals to n is always differ from 0. So the limit of n over bn when n tends to infinity equals to say n over m no እናገኛለን ማለት ነው። Now when we come to the sixth part, for every an which is positive for an is positive number, positive, which is for every an functional value an is greater than 0, we can say limit of the sequence which is square root of an as n approaches to infinity is exactly equals to the square root of the limit of the sequence an as n approaches to infinity, which means this is exactly equal to simply square root of n ሆኖ እናገኛለን ማለት ነው። እና የan value ከዜሮ የሚበልጥ ከሆነ ማለት ነው as n tends to infinity the limit of square root of an when n tends to infinity equals to square root of limit of the sequence an when n approaches to infinity. The result, because of this value equals to say simply n, so the result which is exactly equals to radical L. All these are we call the some properties or theorems of sequences on the limit, or we can say limit theorems on sequence ናቸው። ስለዚህ በእነዚህ መሰረት ሌሎች በርካታ ጥያቄዎችን መስራት እንችላለን ማለት ነው። እነዚህ ቤዚክ የሆኑ limit theorem ብለን እንጠራቸዋለን። some basic limit theorems on sequence ብለን each of the following limits, evaluate the following limits. The first part is limit 3 n square plus 4n plus what over 2n square plus 3n plus 2. B part, let's say limit n plus 1 over n as n tends to infinity when n tends to infinity. The other part is say limit of cos pi n over n square 3n square plus 5 cosine of pi n times 3n square plus 5 when n tends to infinity. Let's say D part, limit of the sequence simply 1 over 3 the power of n minus n when n approaches to infinity. A limit of 2 the power of n plus 3 the power of n over 6 the power of n as n tends to infinity. The last part is f, the limit of the square root of, let's say, n squared plus 1 minus 3 over let's say n plus 2 when the value of n approaches to infinity. Look, so if you understand what we learned before in class, we must calculate all this, the limit value of all these sequences easily. Now when it comes to the solution part, solution, the first part is the sequence is given in A, the sequence is simply an, so n equals to 3n squared plus 4n plus 1 over 2 times of n squared plus 3n plus 2 we get given here. Now we are asked to find the sequence, the limit of the sequence as the value of n approaches to infinity, what will be the functional value of the sequences. So here we can say limit of 3n squared plus 4n plus 1 over 2n squared plus 3n plus 2 when the value of n approaches to infinity. What will be the limit of all this? ይሄን ነው የሚለን እንግዲህ ይሄን ስንሰራ ካሁን በፊት ተናግሬያለሁ ታስታውሱ ከሆነ እንዲህ አይነት የራሽናል ፋንክሽን ፎርም ከመጣበት because of polynomial over polynomial which is called what rational function, so we must divide every terms from the denominator and the numerator by the highest degree of coefficient degree of what the value here in the denominator part. ስለዚህ ምናካፍለው በማን ነው? ዲኖሚኔተር ፓርቱን ትልቅ ዲግሪ የያዘውን ቫሪያብል በሱ እናካፍላለን ማለት ነው። ያ ማለት ምን ማለት ነው? limit of the value, so ምንድነው እዚህ ጋር ያለው አሁን 2n squared plus 3n plus 2 ከሚለው ትልቁን ዲግሪ ያዘው ማለት ነው 2n squared ነው. So every terms from the denominator and the numerator we must divide every terms by what? n squared. Therefore here we can say 3n squared this 3n squared over n squared, so becomes 3. So we can say here 3 plus again here 4n divided by n squared, we can say 4n by n squared, so n by n cancel out, the result is simply n, so which is equal to 4 over n plus, and again this 1 divided by n squared, simply 1 over n squared over here, and from this part we can say 2n squared divided by n squared, we have the result, we simply say 2 plus 3n divided by n squared, 3n over meaning that here 3n over n squared means which is n by n is cancelled out, which is called simply 3 over n, so the result is 3 over n plus here 2 is divided by n squared, we can say 2 is divided by n squared. We can evaluate this as n is approaches towards infinity, as the value of n is approaches to infinity. We have here, look, when you observe here 4 over n as n tends to infinity, this value becomes 0, as this also value becomes 0. And again 3 over n, when n tends to infinity, this value becomes 0 and this value becomes 0. So what's left here is that the limit of all this, the result, which is exactly equals to as our answer, which is exactly equals to here 3 plus this result is 0 over 2 plus 0 plus 0. Therefore our answer should be simply the limit of this sequence when n tends to infinity, the result is equal to 3 over 2 የሚለውን እናገኛለን ማለት ነው። እና እንደምታዩት እዚህ ጋር ራሽናል ፋንክሽን ቅርጽ ነው የተቀመጠልን when n tends to infinity ያካፍል ነው እንግዲህ ከዲኖሚኔተር ውስጥ ትልቅ ዲግሪ ያዘውን ቫሪያብል ወስደን ለዲኖሚኔተርም ለኑሜሬተርም ለሁሉም ተርሞች ማለት ነው ለዛ ቫሪያብል ስናካፍላቸው እንደዚህ ቅርጽ ያዘልን። እንደዚህ ቅርጽ ሲይዝ ይሄን 4 over n ስታዩት 4 over n let's say simply 4 over n means as the value of n becomes larger and larger, this system becomes what? Simply 0 ይሆናል ማለት ነው። The same fashion 1 over n squared, 3 over n, 2 over n squared, the same fashion which is 0. So the result is 3 over 2 ሊሚቱ ይሆናል ማለት ነው። በሌላ አነጋገር n equals to 3n squared plus 4n plus 1 over 2n squared plus 3n plus 2 የሚለው ራሽናል ፋንክሽን ቅርጽ ብትቀይሩት ወደ ቫሪያብል x ስለዚህ ይሄ የራሽናል ፋንክሽን ሃይስት ቫልዩ የምታገኙት የኤክስ ዋጋ ቨሪ ላርጅ ነምበር አፕሮች ሲያደርግ ዋይ ወይም ደግሞ ኤፍ ኦፍ ኤክስ ዋጋ ወደ ሆሪዞንታል አሰምፕቶቱ አፕሮች ያደርጋል። ያ ሆሪዞንታል አፕሮች ደግሞ ተመሳሳይ ዲግሪ ስላላቸው በአጋጣሚ እነዚህ 2 ስኩዌር ተመሳሳይ ዲግሪ ስለሆነ coefficient of the degree this coefficient of this the leading coefficient which is 3 and leading coefficient which is an over bn ሆኖ እናገኘዋለን ማለት ነው። This is the limit of the sequence n plus 1 over n when n approaches to infinity. Now this becomes, assume that this is a sequence an and this is a sequence bn, which is the first formula. So the limit of the sequence an, which is n as n approaches to infinity, plus limit of the sequence 1 over n as n approaches to infinity. So the result becomes the value of when n approaches to infinity. So this result is what? Infinity plus when n approaches to infinity, this result becomes 0. So infinity plus 0, the result which is equal to say infinity ነው እናገኛለን ማለት ነው። እና ምንድነው ይሄን ሲኩዌንስ እንደ an ኮንሲደር ብናረግ ይሄኛው ሲኩዌንስ ደግሞ 1 over n እንደ bn ኮንሲደር ብናረግ so የመጀመሪያው ፎርሙላችንን እናስታውስ limit of the sequence an plus bn when n approaches to infinity is equals to limit of the sequence an when n approaches to infinity plus limit of the sequence bn when n approaches to infinity የሚለው ነገር በሚለው ተጠቅመን መስራት እንችላለን ማለት ነው። When you come to C part, it says the limit of the sequence cosine of pi n over 3n square 3n simply 3n plus 5 3n plus pi n square plus 3n plus 5 we have here as the value of n approaches to say infinity, the value of n approaches to infinity. So the result of this is exactly equals to, since the value which is cosine, so the cosine is as a function, we can say the limit, as you have to recall here, the limit of the function square root of n as in tends to infinitive as this square root is a function which is called simply the square root of limit of the function an as n approaches infinity. So the result becomes simply the cosine of here, the value limit of the sequence which is pi n square over 3n square plus 5. When the value of n is approached to infinity, we can say in such a case. So this when this is equals to cosine value, which is the limit of the function. When we divide every terms of the value here by the highest degree of the denominator parts, we can say here pi n square divided by n square. The result simply pi, and again 3n square by n square, which is simply 3 plus, and again 5 divided by n square. The result is 5 over n square. So we have to have here the value when n tends to infinity, like this. So when you come to take the limit here, the limit functional value here, that the 5 over n square we observed before in the previous part, this becomes 0. The result is 0. So the function value cosine of here pi over the limit pi over 3 plus 0, which is equal simply pi over 3. So the limit value is equal to simply cosine of pi over 3, but cosine of pi over 3 as a functional value or trigonometric function you have to equal, which is equal to 1 over 2. So the limit is exactly converges to some fixed real number, which is 1 over 2. When you come to the fourth part, is D says that evaluate the limit of the function 1 over 3 the power of n minus n, which is limit of 1 over 3 the power of n minus n as n tends to say infinity, like this. This is exactly equals to when to apply the basic limit theorems an plus bn rather than an minus bn. So the result which is equal to say here it is minus. So assume this is an and this is a bn. So we can say limit of the sequence 1 over 3 the power of n when n approaches to infinity minus limit of the sequence n when n approaches to infinity. Therefore here this result is exactly equals to the limit of the value 1 over 3 as n tends to infinity. This 1 over 3 means 1 over 3 the power of n means simply 1 over 3 the power of n. So that 1 over 3 the power of n, when the value of n becomes larger and larger, this value is very huge number. So 1 over very large number, so the result becomes or converges to what? Some fixed number, which is 0. So this becomes the value which is 0 minus, but limit of the sequence n when n tends to infinity, the result which is equal to infinity. So our answer should be which is equal to negative infinity. No, እናገኛለን ማለት ነው። በጣም ቀላል። ይሄኛው እነዚህን ፎርሙላዎች እያየን መስራት እንችላለን ማለት ነው። When we come to a part, which is limit of the sequence a, evaluate the limit of the sequence limit of the sequence 2 the power of n plus 3 the power of n over which is 6 the power of n when n is approaches to infinity in such a way. So this can be simplified as a value limit of the sequence, which is we can say 2 the power of n over 6 the power of n plus 3 the power of n over 6 the power of n when the value of n is approaches to infinity. Because we have a form here, say for example, a plus b over c means that which is a over c plus b over c we have here. Therefore, which is 2 over 2 the power of n plus 3 the power of n over 6 the power of n means that 2 the power of n over 6 the power of n plus 3 the power of n over 6 the power of n. So will be for መቀየር እንችላለን። So here ምን ማለት ነው ታዲያ? Limit of the sequence here 2 the power of n over 6 the power of n means here 2 the power of n over 6 the power of n means simply 2 over 6 the power of n. We have here simplified, which is equal simply 1 over 3 the power of n. In the same fashion, which is 3 the power of n over 6 the power of n. 3 the power of n over 6 the power of n means that which is 3 over 6 the power of n, which equals to 1 over 2 the power of n. Therefore, here we can say this becomes a limit of the function, which is 1 over 3 the power of n plus 1 over 2 the power of n. So the limit as n tends to infinity. So this is equals to limit of the sequence 1 over 3 to the power of n when n approaches to infinity plus limit of the sequence 1 over 2 to the power of n when n approaches to infinity. So we know that the limit of this sequence 1 over 3 to the power of n when the value of n becomes larger and larger toward infinity, the result which is equal to 0, and again this becomes the same fashion which is equal to 0. So our answer should be which is equal to 0. So the limit of the sequence 2 the power of n plus 3 the power of n over 6 the power of n is at n tends to infinity. The result becomes say 0 ሆኖ እናገኛለን ማለት ነው። እንግዲህ ይሄን እዚህ ላይ እንጠይቃቸዋል ሞር ሲምፕሊፋይ ማድረግና የቤዚክ ሊሚት ቴዎረም ላይ የሲኩዌንሱን ያየናቸውን ቅርጾች ማምጣትና አፕላይ ማድረጉ ይቀላል ማለት ነው። ያ ማለት አሁን እዚህ ጋር ምንም አላደረግንም ሲምፕሊፋይ አደረግነው ይሄን የዚህን ሩል ተጠቅመን ማለት ነው። ይሄን ከዚህ በኋላ ደግሞ የዚህን የኤክስፖኔንሻል ፋንክሽን ሩል ተጠቅመን ሲምፕሊፋይ ካደረግን በኋላ ለምሳሌ እዚህ ጋር 1/3 the power of n as n tends to infinity ማለትና limit of 1/2 the power of n as n tends to infinity በሚለውን ስናይ ምክንያቱም ሬዲየስ ኮንቨርጀንስ ከአንድ በታች ስለሆነ እዚህ ጋር የn ዋጋ very large ሲሆን ለምሳሌ ይሄኛው ብታዩት 2 the power 1/2 the power of n ማለት ምን ማለት ነው 1/2 the power of n ማለት ነው። therefore የn ዋጋ very large ሲሆን 1/n በጣም ትልቅ ቁጥር በሚሆንበት ሰዓት አንድ ሲካፈል ለትልቅ ለሆነ ቁጥር የምናገኘው ዋጋ 0 ሆኖ እናገኛለን። so the limit of this becomes 0 ሆኖ እናገኛለን ማለት ነው።